I am Kat Navarro, Lee Awareness Ambassador with the B Foundation for Brain Aneurysm Prevention. I'll be speaking with one of the recipients of this year's Brain Aneurysm Preventative Research Grant Program, Dr. Sean Polster at the University of Chicago. Thank you for being with us, Sean.
Thank you for having me.
So before we dive into your research, just I'd love to know more about you and how you got into neurosurgery.
Yeah, so I did my medical school at the University of Wisconsin, where I met a neurosurgeon that is a cerebrovascular surgeon. He took me under his wing, and the rest is history after that. I went on to do my residency at the University of Chicago, where I worked with another cerebrovascular surgeon, Issam Awad. And studied brain vascular malformations, including aneurysms and all types of brain bleeding. I spent 2 years of my residency devoted to basic science research into microvascular inflammation and vascular remodeling in the central nervous system. And then after graduating residency, went on to do a capstone fellowship at the University of Pittsburgh in skull base and open vascular procedures. Now that I'm was recruited back to the University of Chicago in my current position, I'm the Safety Endowed Faculty Scholar, and I have an NIH funded laboratory that looks at brain bleeding. We do that in a multitude of ways with imaging biomarkers, which the B Foundation is supporting a novel avenue. That we're looking at to understand some of the mechanism and the biology of unruptured cerebral aneurysms, as well as other novel pathways looking at like the brain-gut axis and how systemic inflammation influences local phenomena within the central nervous system. That's my research practice, complements my clinical practice as a cerebrovascular and skull-based neurosurgeon, where we encounter some of the problems that the B Foundation is ripe to help us answer. I see a lot of aneurysms in my practice, both ruptured and unruptured. And in the unruptured group, it's difficult to know, who is really at risk within that group.
Right.
How do we follow patients? How long do we follow patients? And that's a difficult risk stratification that in the modern era we don't have great tools, but as technology and MR imaging and our understanding of the biology has progressed, we're now apt to use some of the modern tools to find answers to a lot of these questions that previously couldn't be answered.
Right, right. We are definitely lucky to be living in this day and age where the technology is advancing fast. And I know that your research could represent a significant breakthrough with just patient monitoring and risk assessment. And this leads into your project. So could you tell us more about the research grant project?
Yeah, so historically, the way that we classify aneurysms is based on their location within the brain as well as their size. This was the best tools that were available, and these were highly selected patient populations that has motivated a lot of the information that we have today. In subspecialty practices, we know where the holes are in that information. But there's also anecdotal things that have popped up over time that has kind of built to, why do aneurysms form? Why do they rupture? Some of the
Hmm.
risk factors are very clear over the last 3 decades. Smoking, Finnish or
Right.
Japanese descent, and again the known things of like where they are located and their size. But within the ones that are located in, these kind of middle risk categories or ones that are of the, medium or small sized, they still do have a rupture risk. Over
Hmm.
time, again, when these studies were done, MR imaging wasn't really prime time, and especially MR angiography, time of flight, black blood imaging. Those are things that have really become modern practice and allowed us to understand and look at aneurysms a lot better. But it still doesn't get to the biology, and there's multiple aspects of the biology, like why do some people get them and other people don't? Why do some
Hmm.
people get them and then they stop growing? And what happens between having an aneurysm and rupturing? Is it a linear process like a balloon where it just grows, grows, and grows and then ruptures? Or can it be at a size of 3 or 4 millimeters and never change and then rupture? And one of the things that has been, talked about is as patients that, have identified aneurysms, is they get MR imaging with contrast. And there are some aneurysms that have the contrast leaks through and they light up. And in the most recent paper on intracranial aneurysms, this is a modern day thing that people know about, but it's not a tool that we totally understand. Right now, there's a thought process that if an aneurysm lights up with gadolinium, it's potentially more dangerous because it has vessel wall enhancement, but there's no data to support that. It makes sense, but unfortunately, logic in the human body and medicine, is not it's not that simple. And that's one of the things that we've looked at for a long time, as with many centers around the United States. Vessel wall imaging has become kind of a standard practice, however, variable between institutions, and especially if you step out of the United States, different between the vendor that the MRI machine is from. And again, in our anecdotal experience, lighting up or not lighting up doesn't really answer the question. We've looked at that a little bit, and again, the logic flows that if an aneurysm lights up and has this dye is leaking through the wall, that is associated with inflammation. So what our grant is really to look at is can we get a more precise measurement of that, and can we follow that to see if how much leak is actually happening. Leak is not as simple. We say this is an MRI and you give dye and you look for the leak, but it's not quite as simple as that. Sometimes there's atheromatous plaques around the origin of the vessel or in the aneurysm itself, or there can be calcifications if it's a long-standing aneurysm, and those can confuse the signal somewhat. So what we've done here at the University of Chicago, we're very fortunate that we have a robust medical physics department, and we work with a lot of the MR vendors. And what we're able to do with Tim Carroll, who's one of my partners here, a medical physicist, is we're actually able to quantitate, the time course of, how does the leak occur over time, and develop a curve of the gadolinium intake and outflow compared to other structures in the brain where there is physiologic leak of the dye. And we think that this will give you a non-binary look of like light up or not light up, but it gives you ones where something is maybe of like a moderate level of gadolinium contrast agent, and that may change over time, and that may correlate with some aspect of risk. Now, with all studies in aneurysms, it's very difficult to correlate any of these findings to the outcome that we really worry about, which is a rupture, right?
Right.
Because if you follow a cohort of patients, if any of the traditional measures change, like an aneurysm shows a growth in size, well, that person's going to immediately move out of observation and go into the treatment arm, right?
Hmm.
And if somebody stays in the normal, observation period, you have to follow them out to, our estimates would put you out to almost 25 to 35 years of follow-up, and that makes a clinical trial very difficult to do, for the logistics reasons of following a patient that long. So what we've really aimed to do is, because we have a measure of how much dye is getting through over a time course, we want to correlate that to other biomarkers. And again, the premise of everything we've talked about historically, what's written in the literature, is that there is some sort of inflammatory process associated with the development and rupture of aneurysms, but we
Hmm.
take that a little for granted. That data is not really robust. I believe it. I think that's how it works. But now that's where the scientists have to come out, and we have to prove that. And one aspect of our grant is that we will follow patients using this risk stratification profile, where in addition
Hmm.
to the traditional metrics of the phases scores, their ISUIA risk percentile, we would correlate that with the K-trans. But then in a subset of patients that are going on to treatment or come out of observation, we would correlate that with known inflammatory markers. And we would do that two ways. If somebody goes for an open craniotomy with a clipping, we will isolate the dome, and then we'll correlate the degree or the metric of K trans, or that contrast flow through the aneurysm, to known inflammatory markers of that tissue. Now, that is not a huge number of people that will be at one center and get, that sequence be followed and then cross over where the dome is able to be isolated. So then we'll have another arm of patients that also get the K-trans MR vessel wall imaging sequences, measure that contrast. And then if they go on to intersaccular or endovascular treatment, we're able to isolate some of that dome blood in a very safe and passive manner, where then we can correlate local inflammatory effects to our imaging biomarker. And this is important for a few reasons. Number one, again, the home run is if we can come up with a better risk stratification metric. That would be great. That's a very
Right.
long-term project, and it has to start with good preliminary data that we would generate here. But what I find very exciting, which has not happened since aneurysms have been discovered, is really what is the mechanism here. If we can get some insight to which inflammatory factors, it allows us to study it better. And this is done in humans. A lot of the information that we have about aneurysms comes from, animal models that just do not recapitulate the human disease or the time course
Hmm.
that we have. So I view these studies as they should sound very rudimentary and very preliminary, because that's the fundamental state that we are in
Right.
with our understanding of aneurysms. I will say that the great way that studies like this fail is hopefully that we just get so much better at treating aneurysms that we can reduce the risk profile over
Right.
each decade, that like even if you have a borderline one, we're much more comfortable to treat those at a much smaller size. But
Right.
I think that's a double-edged way to look at it, because people are living longer. The average age at which I see somebody have an incidental discovered aneurysm, because of the ubiquity of getting vascular imaging, has gone up in the United States, and the aging population interfacing with advanced medical care is also going up in affluent centers around the United States. So we do see people where it would be great to know if we could really define the natural history to avoid any potential unnecessary treatment or any problems, or
Right.
again risk stratify them. So I view this as this is the beginning of a 20-year project, but it has to
Right.
start here, and we have to answer these questions. So I'm very excited to be doing this work, and I think we have a great team here at the University of Chicago, as well as if you look over the B Foundation's history. It's a small community of people that are interested in understanding the mechanisms behind aneurysm formation and rupture, and these are all collaborators that you see through this foundation. So I'm excited to work with this larger group and get some answers here.
Thank you so much for explaining that. That kind of went into the next question I was going to ask, which is basically what success would look like for you in terms of this research project. And you kind of talked about on how it will be a long process. As I was going to ask what the next steps would be. And is there anything else you want to add to that? I feel like you explained it pretty well.
Yeah, I think with any preliminary data generation, we would have our eyes set on ramping up and validating the preliminary data. Usually that traditionally is done under the heading of an NIH grant funded by the government, because it would require multi-center engagement, and going to large numbers. I view that as a success if we can get the preliminary data to show that this is a worthwhile endeavor, and then also to really get the nuts and bolts of what the larger multi-center trial would look like in order to really understand the statistics and the population of a recruitment design. We need some preliminary data to understand the event rates. How easy is it to detect these things in the literature? Everything I've talked about has been talked about in the literature, but now putting it into a prospective design, that's a novelty that can only be done with foundations such as the B Foundation. But moving it to that next level, I view that as the next step, and that's where our arrow is aimed right now.
What does it mean for you to get this grant with the B Foundation on behalf of the Matthew Friedman Memorial Foundation?
Yeah, I mean it's huge. It touches in so many aspects. My the majority of my adult life is has been in neurosurgical training. I've taken care of, thousands of patients with vascular disease. And we're vascular disease is it's a great field. We've made so much advancements even from when I was a medical student at the University of Wisconsin, talking about what the future would look like here in 2025. And a lot of our understanding and technology is advanced, but we still have a long way to go. Having getting an award like this, as well as the recognition, I view it as investment from the wider community in some of these ideas, and that's a huge honor. To have it be named, after a patient that has suffered and experienced through this, and engaged with a group of people that have personal experience with this, I that's also a very important thing. There this disease, aneurysms, whether unruptured or ruptured, have a significant toll on people's lives, and it's to know that there's a community working on these things to lessen that burden. I feel privileged to be a part of that. I've already, I tell my patients, there are groups working on this. This is an area of focus for the NINDS at the NIH and the U.S. government. It's a focus of major research institutions, and also to have that patient engagement. It's the full force. And looking into other diseases over the course of modern medicine, that's where real impact comes from, in my opinion. If any one of those pieces is missing, it's very difficult to make major transformative impact in something that is not, the most common disease in the world, right? And this is
Hmm.
filtered through to other rare diseases, and it's the trifecta of engagement. And I'm so excited to be a part of that, and engage, on all levels of that, and be kind of one of the people that try to push that to the next level. I view that's what places like the University of Chicago and other large universities do, is we find out what the problems are, what the pain points are, and use modern technology to solve some of these problems. And this is all happening right here, right now. And I feel so fortunate to be a part of it. And I hope that the patients know that it's their advocacy, their telling their stories that get us to this point.
Yes, thank you so much for sharing about your research. Congratulations on the research grant award, and we look forward to seeing you at the gala.
Perfect. Thank you. I'm very excited.
Thank you.